Chapter 3 starts off with a review of factoring polynomial expressions. So there's really nothing new here. You've done all this in Math 10, but nevertheless, let's go through what you learned in Math 10. And you may see some trinomials that look a little different than the ones that you were exposed to in Math 10. Let's first look at factoring trinomials. So trinomials of the form x squared plus bx plus c, where there is no leading coefficient, or more accurately, the leading coefficient is 1. And also trinomials of the form ax squared plus bx plus c, where a is something other than 1. Now, the simpler form here, x squared plus bx plus c, we learned a pattern that if this can be factored, it's simply the product of two binomials. And the way to come up with those two binomials is to look for two numbers whose sum is this middle coefficient, b, and whose product is the last coefficient, c. So let's get right into some examples. Let's say you have the trinomial x squared plus 5x plus 6. So you're looking for two numbers with the sum of 5 and the product of 6. And those two numbers are 2 and 3. So what do you do with those two numbers? Well, you write out two binomials, both starting with x, and paying attention to the sign of the two numbers, you simply write, since it's positive 2, you write x plus 2, and it's positive 3, you write x plus 3. Now, it's very easy to check with factoring that you have the correct factoring just by multiplying. So you can multiply these two binomials using FOIL. You would get x squared plus 3x plus 2x plus 6, and those two middle terms, the 2x and the 3x, combine to give you 5x. It's always a good idea to check with factoring that you've got the correct factors. So let's take a look at a couple more. X squared minus 8x plus 15. So the two numbers we're looking for have a product that's positive but a sum that's negative. That tells you right away that both numbers are negative. So if both numbers are negative, their product is going to be positive. And in this case, we're looking for two numbers with a product of 15. Usually I just think in terms of positives. So 3 and 5 give you a sum of 8. So if it's negative 3 and negative 5 gives you a sum of negative 8. So negative 3 and negative 5 are the two numbers. So therefore we can write the binomials as x minus 3 and x minus 5. Let's try another one here. X squared plus x minus 42. So here we're looking for two numbers that have a product that's negative and a sum that's positive. Now, the negative product means that one of the numbers is negative, the other number is positive. So again, I usually just focus on 42. Don't think about whether it's negative 42 or positive 42, just 42. And think of numbers that, pairs of numbers that multiply to give you 42. So there's quite a few, 1 and 42, 2 and 21, 3 and 14, 6 and 7. Now, because one of them is going to be negative and the other positive, what we're really looking for here is a difference of 1. And so the two numbers we want are 6 and 7. But a very common mistake is to get the signs wrong. Since we want positive 7, positive 1 for the sum, it has to be negative 6 and positive 7. So those are the two numbers that give you the right product and sum. And you can write out the binomials as x minus 6 and x plus 7. So at this point, it's important to emphasize that the order of the two binomials is unimportant. If you wrote it as x plus 7 times x minus 6, that's the same thing. Doesn't matter the order in which you write the factors. Now, what if you have something like 3x squared minus 6x minus 24? Can you factor this the same way? Well, initially you look at it and you say, well, it doesn't have a leading coefficient of 1. It's got a leading coefficient of 3, so I'm going to have to use some other method. But don't forget, the first step when you're factoring anything should always be to look for common factors. In this case, the three terms have a common factor of 3. Once you pull out the 3, you're left with x squared minus 2x minus 8. And this is a straightforward trinomial like the ones we've already done. And you're looking for two numbers with a product of negative 8 and sum of negative 2. and those two numbers are negative 4 and 2. So you can write this trinomial as a product of binomials x minus 4, x plus 2. The 3 doesn't disappear, though. The 3 stays out there at the beginning, and so you end up having 3 factors, 1 monomial and 2 binomials. Now, you may see some more unusual looking trinomials, something like this, for instance, x minus 3 squared plus 12 times x minus 3 plus 35. Now, it may be tempting to expand the x minus 3 squared and expand the product 12 and x minus 3 and then collect all the terms and then factor. But you should think of factoring and multiplying or expanding as going in opposite directions. So if your task is to factor, you don't want to start by heading in the wrong direction. So always look for patterns that will help you factor things like this. And one of the patterns here is to replace that binomial x minus 3 with something simpler. So for instance, if I just replace every instance of x minus 3 with a, then what I end up with is a fairly simple looking trinomial, which is a squared plus 12a plus 35. And so now I'm just looking for two numbers with a sum of 12 and a product of 35. Those two numbers are 5 and 7. And I can simply write this as a plus 5 and a plus 7. But you can't leave it like that because the original expression had nothing to do with a. So you have to replace the a's with the x minus 3's. So you have x minus 3 plus 5 and x minus 3 plus 7. And don't leave it like that because that's not simplified. So you have to simplify each factor. X minus 3 plus 5 is x plus 2. And x minus 3 plus 7 is x plus 4. Now, there may be, when you do this sort of substitution, some common factors that you can pull out at the end. So the last thing you should do before you move on to the next problem when you're factoring is always to see if any of the factors can be further factored. In this case, there is no further factoring to do. It's also a little more difficult to check this because if you just multiply x plus 2 and x plus 4, you're not going to get the original expression. If you really wanted to double check, you could do what I suggested you don't do at the beginning, which is expand, collect the terms, and then verify that it does factor as x plus 2, x plus 4. Now, what if the coefficients are not integers? So what if you have something like 1/5 x squared minus 3/5 x minus 8? Well, when you're factoring, you always want to be factoring integers. And so you always want to start with something that has integer coefficients. So in this case, if you can pull out a factor that leaves you with an expression with integer coefficients, that's what you want to do. And because two of the terms are fractions with a denominator of 5, 1/5 is going to help us create an expression with integer coefficients. So taking out a factor of 1/5, well, what does that involve doing? It essentially means you're taking each term and you're dividing it by 1/5. Well, dividing by a fraction is the same as multiplying by the reciprocal. So dividing by a fifth is the same as multiplying by 5. So when you multiply the first term by 5, you just get x squared. When you multiply the second term by 5, you get minus 3x. And when you multiply the third term by 5, you get minus 40. And so now we have a trinomial with integer coefficients. We can go ahead and factor it in the normal way, looking for two numbers with a product of negative 40, sum of negative 3. Those two numbers are negative 8 and 5. And so you end up with x minus 8 and x plus 5. The 1/5 doesn't go anywhere though, so you have to have that 1/5 out front. So don't start factoring until you have an expression with just integer coefficients. Here's one with some decimal coefficients, 0.1x minus 1.6x plus 6. So again, we want to take something out, and there should be a squared exponent of 2 on the x there. the leading coefficient is usually a good bet as to what to take out here. So if you take out the leading coefficient, which is 0.1, you're dividing by a tenth each term, and that's the same as multiplying by 10. So we're going to take each term and multiply it by 10 and end up with x squared minus 16x plus 60. And so all the coefficients are integers. We can look for two numbers with a product of 60, sum of negative 16. Those two numbers are negative 6 and negative 10. So we can write our binomials x minus 6, x minus 10, and of course we've got that 0.1 out front, which you could write as 1/10 instead of writing it as a decimal if you want. Now, what are we going to do with the trinomials that have a leading coefficient which is something other than 1, and it's not a common factor? So let's take a look at an example. 2x squared plus 7x plus 6. Now, in Math 10, you were introduced to one method. Some of you already learned or were taught a different method, and I'm going to explore both of them. So the method that was presented in the textbook in Math 10 was to take the first coefficient and multiply it by the last coefficient. 2 times 6 is 12, and then you look for two numbers with a product of 12, 2 times 6, and a sum of that middle coefficient, 7. So in some ways it's pretty similar to the method we use to factor the simpler trinomials. We're still looking for two numbers with a given product and sum. The sum comes from that middle coefficient. The product, though, is not just the last coefficient, it's the product of the first and last coefficients. So the two numbers in this case are 3 and 4. But here's where it gets quite different from the previous technique. You can't just write two binomials, x plus 3, x plus 4. What you have to do is break apart that middle term, 7x, into two terms, using the numbers 3 and 4. So 7x is going to become plus 3x plus 4x. And you've still got the 2x squared out front and a plus 6. So we've turned this from a 3-term polynomial into a 4-term polynomial. Now, the order of whether you write it as plus 3x plus 4x or the other way around, plus 4x plus 3x, doesn't matter, but it does lead to a slightly different third line in this problem. Now, at this point, you're going to factor this by decomposition, which means you're going to break it down into two separate factoring problems. The first two terms, you will look for a common factor, which in this case is x, leaving you with 2x plus 3. And then the second two terms, you will look for a common factor, which in this case is 2, leaving you with 2x plus 3. Now you can see that common binomial factor of 2x plus 3. You're guaranteed to get a common binomial factor if you have found the two numbers, 3 and 4 in this case, correctly. And then once you have identified the common factor of 2x plus 3, pull it out, and what are you left with? You're left with the binomial x plus 2. And again, this is pretty easy to check. You can just use FOIL to multiply those two binomials and verify that you get the original polynomial expression. Now, how would you do this the other way? So the other way, which is essentially what I call guess and check, uses a little bit of logic, if you like. You know that if you're going to be able to factor this, it's a product of two binomials. So if you look at the 2x squared, the coefficient 2 is a prime number. There's really only one pair of numbers that multiply to give you 2, and they are 2 and 1. So you can put one binomial as starting with 2x, and the other one is starting with x. 6 has a couple of different possibilities. You could have 1 and 6, or 2 and 3. And because the binomials are now different, one starts with 2x and one starts with x, you've basically got 4 different possibilities you have to think of here. And one way to keep track of all the possibilities is to set up a little crisscross method. You can use 2 and 1 or 2x and 1x, and then go through the 4 possibilities in this case. So 3 and 2, 2 and 3, 6 and 1, 1 and 6, and ultimately you'll settle out at the 3 and the 2. Now, the crisscross is meant to help you keep track of that middle term. The middle term, 7x, is going to be the result of adding two products. So in this case, 2x times 2, which gives you 4x, and 3 times x, which gives you 3x, they add together to give you 7x. And so you know that the binomials are 2x plus 3 and x plus 2. So essentially that crisscross, if you like, is the second and third terms in FOIL. And if you try the other possibilities, for instance, switching the 3 and the 2, or putting in 1 and 6 or 6 and 1, you'll see that you end up with different crisscross products, which would mean different middle terms. If you like this method and you want to use it, fine, go ahead and use it. It's still a good idea to know how to do it the first way, because it will help you with some problems where the coefficients are variables themselves. You may remember some of those from studying for the Math 10 Provincial. The other problem with the crisscross method or the guess and check method is that sometimes there's an awful lot of possibilities to go through. So for instance, if you were given the problem 12x squared plus x minus 6, 12 is certainly not a prime number. You have 1 and 12, 2 and 6, 3 and 4 to worry about. And then at the other end you've got 6, which is 1 and 6, 2 and 3, but it's negative, and that throws in another wrinkle because it could be 1 and negative 6, negative 1 and 6, could be 2 and negative 3, negative 2 and 3, and then you have all the positional things to go through as well. There's an awful lot of possibilities to go through here, whereas if you do it the method that was taught in the Math 10, you multiply 12 times negative 6, and you get a product of negative 72. So you're looking for two numbers with a product of negative 72. The middle coefficient is 1, so a sum of 1. And again, when you're doing this sort of thing where the product is negative, just think of numbers that give you a product of 72. And because it's negative, you're going to look essentially for a difference of 1. So it's obviously 8 and 9. Since you want a positive sum of positive 1x, it's going to be negative 8 and positive 9. And you just simply break apart that middle term, and it becomes minus 8x plus 9x minus 6. And you factor this by decomposition, looking for a common factor in the first two terms, which is 4x, leaving you with 3x minus 2. And then you have a common factor of 3, leaving you with 3x minus 2. And the common binomial, 3x minus 2, gets pulled out, leaving you with 4x plus 3. Now, I think this is probably faster than using the guess and check method for this particular example, but certainly when the numbers are smaller or when the coefficients are prime, the guess and check is pretty efficient. So if you want to use both, by all means, use both. Now, there's also one more pattern that is introduced or reintroduced in this section, and we've already seen this pattern in chapter 2, and that's the difference of squares pattern. And we had to use that a lot for simplifying radicals. So you could get a straightforward binomial difference like this. As soon as you see a binomial, you should think difference of squares. And this just simply factors as a product of conjugates, x minus 2, x plus 2. However, you might see some difference of squares that look a bit more unusual. So for instance, it might be a binomial squared, 2x minus 3 squared, minus another binomial squared, x plus 4 squared. Now, in this case, you could expand, collect terms, and then factor, but that's almost guaranteed to take a lot longer. The way you have to think of this is it's simply a difference of squares. So I simply set up my two conjugates, one with a minus, one with a plus, but instead of having nice little monomials, I'm going to have binomials. So I'm going to start each with 2x minus 3, and I'm going to finish each with x plus 4. And then I have to simplify the results. So in the first conjugate, if you like, I've got 2x minus x, so that's just x, and I have minus 3 minus 4, so that's minus 7. And then I have 2x plus x, that's 3x, and minus 3 plus 4, that's plus 1. So again, it's a little difficult to check because you could multiply those two binomials and you'd have to compare it to something else. In other words, you'd have to expand 2x minus 3 squared and x plus 4 squared collected terms. But that's definitely going to be a lot faster. If you can't see the pattern at first, you might substitute a for 2x minus 3 and b for x plus 4, and then you would just see it as a squared minus b squared. But I don't think you'll need to do that after you've done one or two of them. You do also always want to look for common factors, because if you see a binomial like 3x cubed minus 27x, you can't recognize it as a difference of squares because neither of the terms are perfect squares. However, the minute you take out the common factor of 3x, you're left with a clear difference of squares, x squared minus 9. And so that factors as x minus 3, x plus 3. And you've still got your monomial common factor out front. So always look for common factors first. Sometimes you won't be able to factor them without pulling out the common factor. It'll almost always make your life easier if you do pull out the common factor.